So we've talked about a system of linear equations, and we've talked about linear inequalities. Now we're going to discuss the system of linear inequalities. So when you have a system, we know that it means two or more linear inequalities when it comes to the system of linear inequalities. And when you're looking for the solution of a system of linear inequalities, we have to make sure that we remember that the ordered pairs that are part of the solution set satisfy all the linear inequalities. So in this case, when we have these two inequalities, in order for this to be a solution, we need to make sure that it makes both inequalities true, not just one, but both. If we know x is 2 and we know that y is 1, then when we substitute those values into the first inequality, you get 1 is less than the negative of x, which is 2 plus 4. 1 is less than negative 2 plus 4, which is 2, and it is, so it satisfies that inequality. For the second one, remember, it has to satisfy both in order to satisfy the system. The second inequality would be 1 is less than or equal to x, which is equal to 2 plus 1, and 1 is less than or equal to 3, so we know it satisfies this as well. So that 2 comma 1 is a solution to both inequalities, therefore it is a solution to the system. Similarly with this one, if we plug in x for 2 and y for 0, you get 0 is greater than or equal to 2 times 2. Is 0 greater than or equal to 4? No, it's not. So therefore, even if it does satisfy the second inequality, because it does not satisfy the first, it is not a solution to the system of inequalities. When you're graphing linear inequalities, you think of the fact that we're talking about linear, meaning it's a line. So for example, if we go back to the idea of y equals mx plus b, if we look at this equation, y equals negative 2/3 x plus 2, if we were to graph this in red, we would notice that it is beginning at 2, because that's the y-intercept, down 2, to the right 3, and we connect our dots and we have a straight line. If we were to say y is equal to negative 2/3 x plus 2, what we're saying is that every point that is on this line is a solution. Now, when we change that inequality, that equation into an inequality, so if we were to graph these two, the very first thing we have to do is put them in slope-intercept form, which takes the form of y equals mx plus b. But remember that your equal to sign is really either going to be greater than, less than, or equal to as well. So the very bottom one, we notice that is already in slope-intercept form. So if we were to go ahead and graph this one, we know that the slope of that line is 1/2, and the y-intercept is -2. So we would go ahead and begin at -2 on the y-axis, and we would go up 1 to the right 2. So that would be right here. Up 1 to the right 2 more. Up 1 over 2. And it is a greater than symbol, as you see here. It does not have the or equal to, so it's going to be a dashed line. And it's greater than, which means that we're going to shade above the line. So we're going to just go ahead and shade this way. The second inequality, which is 8x plus 4y is less than or equal to 12. When we transform this into y equals mx plus b, or standard form, we are going to subtract the 8x, and now we see that everything that we have learned about solving inequalities, -8x plus 12, is important, because in order for us to transform this, we have to actually put it in proper form. So we divide everything by 4. And your new inequality is y is less than or equal to -2x plus 3. So now we're going to begin at 3 on the y-axis. The slope is -2, so you go down 2 to the right 1, down 2 to the right 1, and keep going. You notice that right now what we just did is we crossed at one point, but that is no longer just the only solution because it's an inequality. This is a less than or equal to, so because it's an or equal to, we need to make it a solid line. And less than means it shades underneath. So we notice that right here in this section here, we are overlapping. And we would write the solution would be here. It's all of that overlapping area. What this is implying is that every point that happens to be in that shaded area, including the points on this green line here, because that's an or equal to, because it includes it, they are solutions. So if we were to check our work, let's say that we were to pick this point right here, which is the origin. That's part of the shaded area. So it's 0, 0. Let's see if it works for both. If we substituted 0, 0, 0 for x and 0 for y, into the top equation, you would get 8 times 0 plus 4 times 0 should be less than or equal to 12. And indeed, this becomes 0, which is less than or equal to 12, so it's a solution to the top one. And for the second one, 0 is greater than 1/2 of 0 minus 2. Well, 0 is greater than -2, so we know that it satisfies that as well. So it satisfies both inequalities, therefore making every point that is in this shaded area overlapping, as well as any point on this green line, since it is part of the or equal to. All of that is part of the solution. No point that is on this dotted line would be a solution, because this does not have an or equal to sign, which means any point on here is not also equal to it. Looking at these two, both of them are slope-intercept form. So if we were to graph the first one in red, the slope is 2, the y-intercept is -3. If we were to graph the bottom one in blue, the slope is 2 and the y-intercept is 2. Hopefully at this point you realize that because both of them have the same slope, they are going to be parallel lines. So let's see what happens, because with a system of equations, of linear equations, they would never cross. But because we're shading, and you notice that this is less than and this is greater, it might be that you're going to shade in between. So let's look to see. Okay, the top one. Begin at -3 on the y-axis, rise 2, run 1, rise 2, run 1. And you make as many points as you want. That is a less than symbol, which is not an or equal to, so we put a dash. Less than means you shade below the line. The blue one, begin at 2, up 2 over 1, rise 2, run 1, rise 2, run 1. And again, this is also a dashed line. And you notice that that one is greater than, and greater than shades above. So there's nothing overlapping. And therefore, this here would be no solution. It's important to note, however, if we would have had the symbols switched. So if the red one had been y is greater than 2x minus 3, and the blue one, so this is an if, and the blue one was y is less than 2x plus 2, then what would have happened is the blue one would have shaded down this way, and the red one would have shaded up, and then they would have overlapped in between. But that is not the way that it was set up, so I don't want to confuse you and have you think that that's how it was. But it is important to see that the symbols make all the difference. If the symbols had been switched, you would have shaded in different directions and they would have overlapped. But in this case, because they are shading on the out going out, it's no solution. For the next example, again, let's do the top one red. Slope is 1. Y-intercept is -3. Begin at -3, rise 1, run 1. It is not an or equal to, so it's going to be just a dashed line. It is greater, so I am going to shave above. And just to make sure, you should also check one of the points. Let's check 0, 0. So 0 is greater than 0 minus 3. Yes, 0 is greater than -3, so I know I shaded that one correctly, so we're going to leave that there. Then the second equation, or inequality, says y equals x plus 1, so the slope is 1 and the y-intercept is 1. So I begin at 1, rise 1, run 1, and so on. It is a less than or equal to, so I'm going to make a solid line. And less than shades below the line. So you notice that even though all of these points over here are part of that blue one, the only overlapping ones are these right here, which we are right in between. So that is what we would say the solution set. And again, to check your work, you pick a point within that shaded area. I would suspect 0, 0, and see if it makes both true. We just checked it for this one. 0 is greater than -3, so let's check it for this one. 0 is less than or equal to 0 plus 1, and yeah, 0 is less than, so it satisfies both. The last one, top one, slope is -3, y-intercept is -2. It's an or equal to, so I know I'm going to go ahead and shade that, make it a solid line. So begin at -2, run, rise over run, so you're going to fall 3 because it's -3. Remember, slope is -3. It's really down 3 to the right 1. You always run to the right. It's a solid line. Less than, shades below. The second one, the slope is also -3 over 1, but the y-intercept is +4. So you're going to go down 3 to the right 1. You notice it's the same slope, so they're going to be parallel. They're both or equal to. And this one is less than as well. So when I go to shade this, the overlapping is just this part here. So basically everything that the blue line had, that was the solution, because that was the overlap. And if you were to check your work, if you were to put 0, 0 in, 0, 0 would only make this red one true. 0 is less than or equal to 4. But if you put it up here to this equation, to this inequality, 0 is less than or equal to -2. No, it's not. It's actually greater than. So you notice that points within this area don't satisfy both, but every point within this area, which is the overlap, satisfies both linear inequalities. Therefore, it satisfies the system. What you're going to do now is complete the independent practice. So you're going to complete these, and you're going to complete these, and you are going to, and this is additional graphs just for you to use as needed, and you're going to complete F5.6 and upload to Canvas. The benefit of using your iPad is that you can use color to show overlap and shading. And email me if you guys have any questions. We'll see you tomorrow.